In the following example, we're asked to determine if the function below is differentiable at the point x equals 2. Okay, so let's figure out first, is the function continuous? Well, let me see here. Let's see, what can I do? Well, when I plug in on x squared, alright, when I plug in 2, what do I get? 2 squared, which equals 4. And in the bottom, 2x, well, 2 times x, or 2 times 2 in this case, equals 4. So we know it's continuous, alright? We know that this function here is continuous. Alright, so let's go ahead and take a look then. We're going to analyze the left-hand side and the right-hand side. Alright, we're going to determine the limit. Alright, so in order for this to be differentiable, the limit must exist, alright, at this point. Alright, let's see here. What do we get? Well, when I do f prime of 2, alright, and I'm going to take the limit as x goes to 2, alright, and in this case it'll be 2 from the left hand side, alright, because that's the function x squared, alright, so f of x minus f of 2 over x minus 2. Okay, so that's what we're looking at there. So what does this equal? Well, this equals the limit as x goes to 2 from the left of what? X squared minus 2 squared, right? Which in this case is 4 over x minus 2. Well, you should start noticing what happens here. This is a special case of, well, not a special case really, this is dots, a difference of 2 squares. So I have the limit as x approaches 2 from the left, I have x plus 2 times x minus 2 over x minus 2. So what happens here is that I can line some stuff out, can't I? The x minus 2's, leaving me with x plus 2 there. So then I get what? I get what? 2 plus 2, which is what? 4. So my answer here is 4. Okay. Now let's check the right-hand side limit. Okay. So f prime of 2, which we're looking at the limit as x approaches 2, in this case from the right hand side, f of x minus f of 2 over x minus 2. Alright, so what does this equal? Alright, let's take a look. The limit as x approaches 2 from the right of 2x minus 4. Correct? So over x minus 2. Now I can do some GCF factoring here. This is the limit right here as x approaches 2 from the right of 2 times x minus 2 over x minus 2. And again, I should notice that I can line some stuff out. So my x minus 2's, I get rid of them, leaving me with a constant, which is 2. Okay. Well, the limit exists on the left-hand side, and the limit exists on the right-hand side. But what can we say about this? Okay, what can we say about this right here? So let me give myself some room to write. So let me scratch this off at the top. Alright, I know it is continuous. However, is it differentiable? Alright, well, let me ask you a question. Does the limit as x approaches 2 in general exist? Alright, so let me erase this. What I'm asking is, does the limit as x approaches 2 of f of x exist? Okay, well, the answer is no. It does not exist. Alright? It does not exist because the left-hand side and right-hand side limits do not agree. So, our function then is said to be not differentiable at x equals 2. And this is how we can prove it using calculus, using limits, but importantly using our background knowledge of algebra. Okay, so it is not differentiable at x equals 2. Good luck.